Welcome to the Electroactive Materials Characterization Lab. This research group focuses on processing microstructure property relationships in smart materials with the goal of developing new materials with unique combinations of mechanical, electrical, and coupled properties. The goal of this research is to solve a wide range of problems in the aerospace, automotive, and consumer industries.
My research lab is called the Electroactive Materials Characterization Lab, and I think it captures the overall topics that I'm interested in terms of research. So we focus specifically on materials that couple between multiple domains, materials that are able to convert electrical energy into mechanical energy and vice versa. Also, in recent years, we've looked at materials that couple between magnetic and mechanical. We've looked in the past at optoelectric materials. And what that means is that these are materials that fit the big umbrella of smart materials. They don't just perform a mechanical function, they're also able to sense or actuate in response to the environment, to a change in their environment.
In terms of broad goal, I'm trying to systematically study a particular set of material, which is, as I told you, electroactive polymer. So my ultimate goal is to see the performance of the polymer, how we can implement them in achieving different kind of smart structures, which in the future can be used in biomedical, aerospace applications. So for this, we need a lot of fundamental study, how we can improve the actuation performance of this kind of polymer, how we can reduce the required electric field to perform them better, and how we can actually enhance their performance in terms of breakdown limit, and so that they can last longer.
Mainly we do thin films, nanoparticles, nanocomposites. We do the processing of these in the lab, and then we do test them for different capabilities or performance.
Main applications are geared towards aerospace. So both aircraft and space applications, where there's a need for materials that are flexible, lightweight, and can perform multiple functions. So that the overall system that contains these materials is efficient. It can accomplish multiple tasks by using a smaller number of materials, if you will. Other applications I'm also interested in are in the medical field or medical area. So it turns out that a lot of the material properties that are needed for aerospace applications are also work very well for medical applications.
Most of the films that we're producing are for the applications of sensing, which is mainly having something like this to sense any force or pressure or actuation. Actuation would be if I apply an electric field to something like this and make it move.
And then there's consumer industry. Because we work with polymer-based materials, some of what we do could also be applicable to that. So just making particular polymers or plastics better.
The ultimate goal of the lab is to transition these electroactive materials into applications that would benefit fields as varied as aerospace, medical, electronics, and consumer industries.